All right, hi guys. So this is 5.7. Now I want to tell you I'm kind of conflicted about this section because you're really gonna do it again, but better in Calc 2. And I'm confused why we're doing it now, why I'm required to teach it. And I think it's because we're trying to expose you to um to this stuff now, right? Right? If you can get ahead on stuff now, awesome. Okay. But the way I'm gonna approach this is, we'll go through this section. It's gonna be pretty quick, to be honest. Um, but on the exam, I will provide you the formulas. You just need to know how to use them, right? Yeah, so like in last exam where I gave you the arctan or arcsin derivatives and you used it, right, with the chain rule or whatever. I will do the same thing for this, right? So for the upcoming exams, I'm not going to provide you those derivatives of arc trig functions anymore, but I will provide you these, which are kind of the three main ones, okay? So if we're looking at the integral 1 over, and then it's a little more general. So instead of 1 minus x squared, it'll be a squared minus x squared dx, okay? So instead of arcsin of x, it's going to be arc sine x over a plus c. Okay. Then what about arctangent? Let's say we have a squared plus x squared. So instead of arctangent, it's 1 over a arctan x over a. And then the last one, arcsecant. So it's 1 over x square root x squared minus a squared dx. This is 1 over a arc secant of absolute value of x over a plus c. Okay. Yeah, so it's adapting it a little bit. Um, so the way we could approach this is do some weird algebra and then do a clever U sub or kind of clever U sub, and you'll get these formulas. Okay. So we could do it. I guess I can show you one of them just so you can see how it looks. Let's look at arcsine. Okay. Just so you know this isn't coming out of nowhere, right? So if we're doing this integral, what we can do is well think the problem is this isn't a one, right? If that was a one, I would know this is arcsine x just right. Well, if you know your derivatives, right, of your arcsine x. But you know, with perfect knowledge, we would know that's arcsine x. So how do I make this a one? Well, I'm going to factor out a squared from both things. Okay. So I have this square root. If I factor out a squared, this is a 1 now. Awesome. And then minus, great. But this is x squared over a squared, right? Because I factored out a squared, but there was no a squared there to factor out. Okay. Now I can I can separate the square roots. Okay. And then here, 1 minus x squared over a squared, I can write that as x over a squared dx. Okay. Then we're going to assume a is positive. So this would normally be absolute value of a, but we're going to assume a is positive. So we just get a. Okay. And that's how we're going to approach the rest of this section. Okay. So this is a 1 over a. I can just factor that out. Okay. And then it's this. And this is great. Okay. Because I can do a substitution here. I can do a substitution. Maybe t equals x over a. So then dt equals 1 over a dx. And then I can multiply by a on both sides to get dx by itself. Okay. So now so this guy in here is t. And then dx, that's a times dt. Okay, so I can do this. So 1 over a. And it's going to be 1 over square root 1 minus t squared. That's awesome, right? Because I know that's going to be arcsine of t. But then I have a dt and the a's cancel. So this is simply the arcsine integral, um, right? This is the derivative of arcsine, but since it's in an integral, we just get back to arcsine of t plus c, and then going back, arcsine of x over a plus c. Okay. And then, yeah, so like I said, weird algebra where we factor out a squared, but this is how you can approach all three of them if you feel like proving them, and you'll get that. Okay. So, like I said, we could do these if we know our arctrig derivatives. Okay. Well, let's try using it. Let's try using it. Okay. How does this look? So let's look at this. Okay, dx. Sometimes you'll see dx over like that. What this is saying is 1 over square root 1 minus x squared, and then dx on the side, right? Because it's multiplication, you could put it in the numerator, and sometimes you'll see that, okay? Um, I generally like it the way on the right, but it doesn't matter. But let's do it. So, um, what's the antiderivative of this guy? Okay. Well, like we've been saying, this is just arcsine. Arc, arc sine of x, 1/2 and 0. Okay. Well, then this is going to be arc sine of 1/2 minus arc sine of 0. Okay. And now we need our unit circle. Okay. If you have a calculator, I think there is an arc sine button. Okay. But you might not get the exact answer. You might get a decimal, depending on your calculator. So let's just think about how we would approach this. What arc sine is saying is your sine, your y value, is 1/2. Okay, so that's going to be here, right? Because it's one, so it's about halfway up and here, right? So that's halfway up the unit circle. And but arcsine only cares about here, okay? Because it's an inverse trig function, the domain is restricted. Remember all the way back to the beginning of the term. So we're really talking about this point. Our sine is going to be 1/2. Now, the arc sine of 1/2 is asking what angle gives you that? What angle gives you, okay, sine of that angle gives me 1/2. Okay. So if you know your unit circle, it's going to be pi over 6. Okay. Sine of pi over 6 gives me 1/2. Yeah. So this will be pi over 6. Same thing for 0. So sine of 0. So it's saying your sine, your y value is 0. And what angle gives you that? Well, 0, right? There is no angle there. So pi over 6 minus 0, pi over 6. Okay. So that's a definite integral example. Let's try some indefinite ones. Let's try integral 1 over square root 1 minus 16 x squared dx. Okay. So the way we want to approach this is we want to find the 1 over square root 1 minus u squared, right? Because that's going to be arcsine. But here it's x squared, which is close, but it's got the 16 on it. Okay. What we can do is stick those together as 1 minus and then 4x squared dx. Okay. Now it's 1 minus something squared. Perfect. Let's call that our u. So this is u equals 4x. du equals 4 dx. I can divide by 4 on both sides. Perfect. And now we can do our integral. So it's 1 over square root 1 minus u squared times a quarter du. Okay, so I can pull the quarter out, and then that's my arcsine. What's 1 over square root 1 minus u squared? So this is arcsine u plus c. And we go back 1 quarter arc sine 4x plus c. Okay. Okay. Let's try it with um, multiple pieces happening. So something like this is going to happen in the previous example, and an extra bit, which we looked at the beginning of this video. Let's look at this. So first of all, this guy's our problem. We need it to be just a variable squared. So we're going to do the same thing we did last time. So we're going to call u equals 3x, right? Because u squared will be 9x squared. Okay. So then du equals 3dx, and we divide by 3. That's dx. So this becomes integral 1 over square root 4 minus u squared times a third du. I can factor out the 1/3. Okay. And you notice this is not quite arcsin. Okay. But we wrote this at the beginning, remember? For a general a. When it's a squared minus x squared, we just get x divided by a. Okay. So here we get 1/3 arcsin u divided by 2. Okay. So remember this is 2 squared right here. Okay, 2 squared. You want to do the square root of it, right? Okay, and then we can go back. U equals 3x, so it's 1/3 arc sine 3x over 2 plus c. Okay. Now using that thing at the beginning of the video, go ahead and try this one. Okay, you try this one. Pause the video here. Okay, hopefully you paused. So this is 3 squared minus x squared, right? So um, we get arc sine x divided by 3 plus c. Okay. Okay, so that's a whole bunch of arc sine. Let's go ahead and get you to try one more, very similar to this example at the top here. Okay, let's do another one. 1 over square root 25 minus 16x squared dx. And then just so when you pause the video, you have the previous example. So again, it's gonna be very similar to this guy here. So pause here, try this example. Okay, hopefully you paused. Um, so I'm just going to put the answer here. Oops. I'm just going to put the answer here. It's very, very similar to this example I just did. Just was numbers slightly different, right? Um, so if you follow the steps that we did in that example, you'll be okay. So what we end up with is 1/4 arc sine of 4x divided by 5 plus c. Okay. So that's a whole bunch of arc sine, whole bunch. Let's move to arctan. These will be the most common ones you see. You will not see, first of all, you won't see the co ones, right? Arc cosine, arc cosecant, arc cotangent. You won't see those. You will very rarely see arc secant, next term, I mean. And yeah, so these two are, this is the third one actually. If you remember what I was talking about with the integral 1 over x dx and integral 1 over ax plus b dx, the third one is actually this arctan integral. Um, so these three build uh, kind of your building blocks for, that section I was talking about in the middle of the Calc 2 term. Yeah, so if you know these, you'll be on top of it for when that comes up. But so let's take a look here, and then just so we have it, let's write the thing that was at the top. So this is 1 over a arctan x over a. Okay. So the important thing here is you're always taking the square root, right? So a squared is in the integral, so we get just a in our answer. Okay. So let's try this example here. Okay. Um, yeah, so very similar procedure, but just with arctan instead of arcsecant, right? So this is giving us an issue because it's not a variable squared, it's 4x squared. Well, so we'll just call u equals 2x, right? Because u squared is 4x squared then. So equals 2x, du equals 2 dx divided by 2. We've been doing this throughout the video. So this is going to be integral 1 over 1 plus u squared times a half du. So we get the half out, and then 1 over, excuse me, 1 over 1 plus u squared. There's no a, right? It's just 1. So this is just arctan u. This is just arctan u plus c, and then we'll go back. So u equals 2x, so arctan 2x. Okay. So go ahead and try this one. It's another one with numbers in both spots, but again, the steps are very, very similar. Steps are very, very similar. Okay, dx. Go ahead and try this example here. Again, very similar procedure to the integral with arcsin that I had you guys do. Okay, hopefully you paused. So yeah, if you do u equals 2x again, right? So we get a half du equals dx, right? Same exact u setup we had earlier. So this turns into a half 1 over 25 plus u squared du. And then we get to use the red piece that we talked about, right? So the 25, so this half sticks in front, but then the 25 gives us 1 over 5 arctan u over 5 plus c. So that's a tenth, and then u was 2x. Okay, awesome. Very, very, very cool. Let's do another one. Yeah, let's do another one. Easier one for you guys. You'll be able to just jump straight to the red thing. Um, So integral 1 over 16 plus x squared dx. Go ahead and pause and try this one. Again, you can do the red kind of tool straight here. Okay, yeah. So yeah, this is 4 squared. So this is going to be 1/4 arctan x over 4 plus c. All right. Let's do a definite integral. All right, we need our unit circle. Okay, so dx over 1 plus x squared. Okay, so yeah, right off the bat, this is arctan x. There's no other numbers floating around, so it's just arctan x. It's the bounds that are going to give us the issue because we need to know our trig, right? So this is going to be arctan of root 3 minus arctan 1 over root 3. Okay, yeah. So plugging in a calculator, or if you know your unit circle, um, just so you have it, let's talk about how I would approach this probably if I didn't have a calculator, but I knew my unit circle, right? So when I'm looking at root 3, I'm going to think of it as root 3 over 1. Okay. And then what I'm going to do is introduce a half in both spots, right? If I divide the top and bottom by 2, it's the same. But notice what I have here. So root 3 over 2 divided by 1/2. Okay. Now, since we're doing arctan, that's, sine over cosine. So this is my sine, this is my cosine. So what angle gives me a sine, a y value, root 3 over 2, and an x value or cosine of a half? Okay. And we could draw it if you want. So root 3 over 2, comma, a half would be about there. So this is an angle of pi over 3. Okay. So arctan of root 3 is pi over 3. That's the angle that gives me that. You can do a very similar procedure here, and you'll get pi over 6. So minus pi over 6. Pi over 3 minus pi over 6. Pi over 6. Okay. Let's try another one. More unit circle stuff. Okay. So I'm going to give you this. I want you to at least get the antiderivative. And if you get the bounds too, awesome. Okay. But at least get the antiderivative here. So pause the video. Okay. So yeah, so right off the bat, this is an integral of the form in the red, right? A squared plus x squared. So this is automatically going to be a half arctan x over 2. But then we got to plug our bounds in as well. Okay. So this would be a half arctan 2 over 2 is 1 minus a half arctan 0 over 2, which is 0. Okay. So 0 is easy. Um, right? Your what angle gives you a tangent of 0? That's just 0. Okay. Arctan of 1, what this is saying is you have 1 over 1, right? Your sine and your cosine are equal to each other. Um, right? If tangent of theta equals 1, right? This is sine of theta over cosine theta equals 1. You can multiply both sides by cosine. Your sine and cosine are equal if tangent is 1. Now, on my unit circle, where are my x and y coordinates the same? Well, it's going to be that symmetrical point right about there. Okay, so it's going to be pi over 4. Pi over 4, right? Think about sine and cosine at that angle. Sine and cosine are both root 2 over 2. Okay, so they're equal. So this is going to be a half times pi over 4 minus 0. So this is pi over 8. Now, with all this unit circle stuff, there's a whole bunch of ways you can do it. That's how I approach it. But yeah, you might have a different system, and that's totally fine. Okay. But yeah, that's the end of this section. Yeah, so it really just comes down to these formulas here. Again, I will provide them, but you need to know how to use them, right? So that's what this whole section was about. All right. Have a good day, everybody.